Hello, this is Mr. Chan here, and today we are going to look at how we derive the geometric series formula. And again, this will involve some crazy shenanigans like we saw last time with the arithmetic series formula, some unintuitive manipulation that you would not be expected to derive on a test or anything like that. But this is, of course, really interesting. And of course, for those of you that want to know a little bit more, this is a deeper depth of understanding. Okay, so let us begin. Again, I'm assuming you know what a sequence, a geometric sequence is, and of course what a series is, which is the sum of a sequence. Now, I've written out similar to the last video where Sn is equal to the sum of the terms in the sequence, but this time our t's are a little bit different. T1 is going to be a, which actually is the same, but T2 is not. It's a r. Then T3 is a r squared plus blah, 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 all the way to a r to the n minus 1. So that's Sn. So last time we wrote out Sn again, and then we reversed the order, and then we added them. This time we ain't doing that. This time what we're going to do is we're going to write it out again, but multiply it by r. What the heck are you talking about, Chan? I'll show you. So let's write it out again. I'm going to leave space there, actually. So again, I'm just writing the entire thing out again. Except this time we're going to multiply the entire thing by r. Why? Well, you'll see, again, some unintuitive garbage. So again, r on this side, multiply both sides by r. So this entire right-hand side is all multiplied by r. So a is multiplied by r, so it becomes ar. Ar is going to multiply by r, so it's ar squared. This is going to be ar cubed now. And then this will just be ar times n. Because, of course, we multiply r to the n minus 1 times another r. That's r to the n minus 1 plus 1, which is just r to the n. Hopefully you remember that. Any hoozle. Now, what do we do? Well, here is where things get a little bit interesting. What we're going to do is take this as equation 1. Take this as equation 2. And we're going to do equation 2 minus equation 1. Why? I'll show you in a sec. 2 minus 1 gives you what? Well, left-hand side turns into RSN minus SN. The right-hand side, now this is where the fun stuff begins. Now, we are subtracting them, not adding them. So when we subtract these two, you'll notice that if I take this one, right, taking this equation and subtracting the first one, I'm taking AR and I'm subtracting another AR. I'm taking AR squared, I'm subtracting another AR squared. And you know this pattern will continue. Okay. Up until what? If I add our second last term in here, which I probably should have done the entire time. So this is going to be AR to the n minus 1 plus AR to the n. So again, this is just the previous term, which of course used to be AR to the n minus 2, but we multiply everything by n, so it's AR to the n minus 1 now. So again, we're adding these two equations. These will cancel out as well. So what are we left with? Well, we're left with this weirdness. We've got an A and an ARN. Okay. So again, what you have to keep in mind is we took this equation and we're subtracting number 1. So it's actually going to be a negative A. Okay, so keep that in mind. So this will be turns into a negative A plus AR to the n. Right? And then at this point, we're almost done. But of course, this was completely unintuitive. We're going to factor out an Sn from the first equation. So it'll just be R minus 1 times Sn. And then over here, we are going to combine the A's. So we're going to factor out A. So this turns into, sorry, I want to rearrange this first. So this is going to be AR to the n minus A. And then I want to factor out an A. There we go. And then now you can see that if I rearrange this, divide both sides by r minus 1, we get this beast over here. Again, not a very fun process, not very intuitive trying to get there, but hopefully you can see that this yellow formula is how we derive, or this derivation is how we derive the yellow formula. Now, in order to show this is equal to the green formula, that's quite easy. All you need to do is take this yellow formula and say, okay, whoa, that's the highlighter, not the pen. This is equal to, I'm going to expand ARN minus A over R minus 1. So again, I factored out A here. I'm expanding it over here to show the green form. And this turns into, oh dear, this turns into AR to the N is equal to Tn plus 1. And then A is just equal to T1, right? So minus T1 over R minus 1. And remember, the reason why this is plus 1 is because this is R to the N rather than R to the N minus 1. If it was N minus 1, it would be equal to Tn, right? So that's our green formula. Where's my lime green? Okay. And now we can see that we've derived the green formula and we've derived the yellow formula. Please let me know if you have any questions. Thanks for listening. Goodbye.